Hello, I'm Seema and welcome to part 33 and the last part of the chapter haloalkanes and haloarenes. In this video, I'm going to talk about polyhalogen compounds. We have studied the halogen derivatives of organic compounds are known as haloalkanes. If it is a derivative of an alkane, it's known as a haloalkane, and if it is a derivative of arene, it is known as a haloarene, and therefore the name of the chapter haloalkanes and haloarenes. When you have more than one halogen in a compound, we call it, in an organic compound, we call it a polyhalogen compound, right? So there may be 2 halogen atoms, there may be 3 halogen atoms. When you have multiple halogen atoms, that is when we call these compounds polyhalogen compounds. Basically, this is the main thing that you must know about polyhalogen compounds. And then there are a few examples that have been given, a few compounds which have been told to you what are their uses, what are the harms of them. And therefore we study these, although from the examination point of view, they may not be asking you the details of which compound is which and what are its harmful effects and what are its uses, but a vague idea of them does not hurt. You must have an idea of what polyhalogen compounds are, which are the ones that are there in your syllabus. So let us just go through them quickly. I have divided the polyhalogen compounds I've tried to divide them into a table, and I've done it for 2 compounds. And I would expect you to take this further for the rest of the compounds also. So what are the compounds that we are going to be studying? You have dichloromethane. Dichloromethane is also called methylene chloride. It is CH2Cl2. Trichloromethane is CHCl3. It is commonly known as chloroform. If you have iodine in place of chlorine, that is 3 iodine atoms, you get CHI3, and it is known as iodoform. So that's your third compound. Then you have all the 4 hydrogens of methane substituted with chlorine, so it becomes CCl4. It is called carbon tetrachloride. So that is one of the compounds. Then you have freon. Freons are fluorine and chlorine derivatives. We call them chlorofluorocarbons, right? Where the hydrogens are substituted by chlorine and fluorine. So they are known as freons, and they are used as refrigerants, and therefore they are very important to us. And you have DDT. DDT is used as a fertilizer, but it is a very ill-reputed one, and it's not a fertilizer, it's an insecticide. And it is diphenyl trichloroethane is the name of DDT, and knowing its structure will not hurt. That is one thing that I would encourage you to see. The structure is given in the textbook. Just look at it, make the structure, practice it a couple of times, and you should be good. The name itself, D, is for dichloro, diphenyl D, and T is for trichloroethane. Right? If you just remember this, the DDT itself will give you a hint of what it is, and if you know the name, you can always draw the structure. Now, why are these polyhalogen compounds so important? They are important because they are industrially very useful to us. They are useful compounds, but with a little bit of salt, and the salt is, I would not say a little bit, with a lot of salt. They have major harmful effects also. Some of them are so toxic that they may cause death. They cause organ failure, they affect your organs, and they may be used in medicines, or like I'll just talk of chloroform, for example, which is used as an anesthetic, or it is not currently used. It used to be used as an anesthetic, but then it was found that it had a lot of toxic effect on the body, and therefore now it has been replaced by other of these what are they called, anesthetics. So let me just take these 2 first. Dichloromethane. If you make a table like this, it helps you to remember them a little, although you need not seriously mug up every line of these. You just need to have a vague idea of each compound. Dichloromethane or methylene chloride, the formula you should definitely know is CH2Cl2. It is used as a solvent in paint remover. Remember, these are all organic compounds, and organic compounds would make, and if they are liquids, they would make non-polar solvents. So they act as a solvent in paint removers. They are used as propellants in aerosols. They they are used as process solvents in the manufacture of drugs. When you are manufacturing drugs, they can be used as solvents there. And it is used as it is as a metal cleaning and finishing solvent. So basically you see that this is a compound which is used as a solvent at many places. Now what are the harmful effects? What happens when you use, what are the dangers of using dichloromethane? The dangers, the harms are, it harms the human nervous system. So it directly affects your nervous system. That is the reason why this class of compounds are really dangerous. They are toxic, they are harmful. It affects the human nervous system. Exposure to very low levels in air. It leads to an impaired hearing. Your hearing is affected, your vision is affected, you get dizziness, you get nausea, you get a tingling and numbness of fingers and toes. All these are effects of your nerves getting affected. If you have a direct contact with your skin, it affects the skin. It causes burning, it causes a mild redness. If it comes in contact with your eyes, the eyes will start burning, it will burn, and the burning would be so severe that it can actually cause the burning of the cornea. You can lose your eyesight simply because of exposure to this. So as vapors or even in air, this can have really toxic effects on the human body. Now we come to the second compound, that is trichloromethane, CHCl3. It's also called chloroform. You have heard about chloroform. When we were kids, we used to hear stories where a thief would come and he would put chloroform in the hanky and he would put it on your nose and you would faint and God knows what will happen after that. But it is extremely, extremely toxic. And when anesthetics, it was used in surgery as an anesthetic, but the doctors used it in very little quantity and still it had some of the harmful effects. Therefore now it has been replaced by other anesthetics. So what are the uses of chloroform? Chloroform is also used as a solvent for fats, alkaloids, iodine, etc. It is used in the production of Freon. We are studying about Freon also. So it is one of the ingredients that is used in the production of Freon, which is used as a refrigerant. And one of the Freon refrigerants goes by the name of R22. And this is used in the production of R22, which is a Freon. And Freons are refrigerants. Your refrigerators have Freons. And it was used as a general anesthetic in the past, but due to its toxic nature, it is replaced by ether and other compounds. What are the harms of this now? It affects the central nervous system. Even 900 parts per million, that is a very minuscule quantity. Even 900 parts per million can cause dizziness, it can cause headache, it can cause fatigue, it can be so toxic that it can harmfully affect you. If you have a chronic exposure to this chloroform, that is for a long time you're getting little, or what do you say, little doses of chloroform in some form. So chronic exposure can cause liver damage, where what happens in the liver, it gets metabolized into a highly poisonous substance which is known as phosgene. Phosgene is COCl2, which is extremely toxic. And it affects the kidneys, it affects the skin. And if you leave it out in the air, in the presence of light and air, it can get oxidized to phosgene on its own. Therefore, you cannot even leave it out in open. It has to be kept in a dark bottle because you do not want it to react with air. You do not want it to come in contact with light. If it does, it would produce phosgene, which would be toxic. Even in very little quantities, it is going to have a toxic effect on you. Now, I'm not going to write down the rest of the compounds, but I would like to read it out to you. And I would expect you to create a table somewhat similar. This would just be a tool that before exams, when you're doing it, you can give it a quick read. Otherwise, of course, it's just 2 sheets in the textbook. You can always read it in 5 minutes. Now, here is chloroform when it reacts with oxygen and it in the presence of light, it results in COCl2, which is phosgene and 2HCl. Now, this reaction may be important. Now, this is what may be asked to you. What happens why do we not use chloroform? So, a question could come in this way. The next compound is triiodomethane or iodoform. That is, the formula would be CHI3. Iodoform used to be used on wounds, as a mother tincture, like it used to be used for dressing. And it was used for dressing because the iodine that was liberated in it acted as an antiseptic. But the problem with it was that iodoform has a very foul smell. So these days, this has also been replaced by other compounds. So, other compounds which may just liberate iodine without the foul smell. I'll just read it. Triiodomethane was used earlier as an antiseptic. So, in use as you write, it was an antiseptic. But the antiseptic properties are due to the liberation of free iodine and not due to iodoform itself. So you don't have to use iodine in the form of iodoform. You can get any other compound that liberates iodine without the irritating smell and yet get the antiseptic effect. So it has been replaced by other formulations containing iodine. The next compound is tetrachloromethane or carbon tetrachloride, CCl4. Now iodoform was CHI3 was iodoform. And CCl4 would be tetrachloromethane. Commonly it is known as carbon tetrachloride. It is produced in large quantities for the use in the manufacture of refrigerants and propellants for aerosol cans. Your perfume bottles are aerosol cans, where you spray and very minute droplets come out. So aerosols are nothing but liquids that are sprayed in such small droplets that they are almost gaseous. So in those aerosol cans, it is used for the manufacture of refrigerants and propellants for such which are fed into aerosol cans. It is also used as feedstock in the synthesis of chlorofluorocarbons. What are chlorofluorocarbons? They are freons. So it is used in the feedstock, which means as the raw material for it. And other chemicals. Why? Because what are freons? Freons are those hydrocarbons which have both chlorine and fluorine. So since carbon tetrachloride has the maximum chlorine, it would make a very good raw material for a hydrocarbon to supply the chlorines. So it is used as the feedstock in the synthesis of chlorofluorocarbons and other chemicals, pharmaceutical manufacturing, and general solvent use. Now, if you do not remember any use of these, one use is that they are all used as solvents. So that is something that you can just write if you were asked about it. Until the mid-1960s, it was also widely used as a cleaning fluid, both in industry as a degreasing agent and in the home as a spot remover and as a fire extinguisher. There is some evidence that exposure to carbon tetrachloride can cause liver cancer in humans, and therefore its use was stopped. The most common effects of inhaling the carbon tetrachloride is that it causes dizziness, it causes light headaches, it causes nausea, it causes vomiting. Basically, these are symptoms of poisoning. When you get poisoned by something, you would have these symptoms. So they are the same symptoms. You would get dizziness, you would get headache, you would get nausea, you would vomit, which can cause permanent damage to the nerve cells, and all of them affect your nerve cells. These effects can lead rapidly to stupor, that is senselessness. Stupor is senselessness. It could, if even more drastic, it could lead to a coma, it could lead to unconsciousness or even death. Exposure to carbon tetrachloride can make the heart beat irregularly, or it can make it even stop. So it is so poisonous that it can actually cause death. The chemical may irritate the eyes on contact. Even mild exposure may act as an eye irritant. When carbon tetrachloride is released into the air, it rises to the atmosphere and depletes the ozone layer. Now, this is another major drawback of these compounds, polyhalogen compounds. Both freons and carbon tetrachloride are known to deplete the ozone layer. Therefore, although carbon tetrachloride is directly affecting you, it is highly toxic, plus it is going and depleting the ozone layer. On the other hand, the freons will not directly affect you. They are silent, in their action. They're going to act very friendly around you, but when they go up, they do deplete the ozone layer. So they are causing harm, not immediately, but in the long term, they are causing us harm. So when carbon tetrachloride is released into the air, it rises to the atmosphere and depletes the ozone layer. Depletion of the ozone layer is believed to increase human exposure to ultraviolet rays. And when we are exposed to the ultraviolet rays of the sun, the chances of getting cancer increase, leading to increased skin cancer, eye diseases, disorders, and possible disruption of the immune system. So let's now talk about freons. The chlorofluorocarbon compounds of methane and ethane are collectively known as freons. Now, those compounds in which chlorine and fluorine both are present together, they are known as freons, and they should be the compounds of just methane and ethane. That is, the hydrogens of methane and ethane, if they are substituted with chlorine and fluorine, they result in the formation of freons. They are extremely stable, they are unreactive, they are non-toxic, they are non-corrosive, and they are easily liquefiable gases. Do you see, they are all such good qualities that make them so attractive to be used. What are the qualities? Let me repeat. They are extremely stable. Nothing is going to happen to them. They'll function for a long time. They are unreactive, again, so that does not denature them for a long time. They are non-toxic. They are not immediately going to harm you. And they are non-corrosive. They are not going to affect the parts of your machine. For example, when we use it in refrigerators or in other machine parts, they are not going to harm the parts. They are non-corrosive, and they are easily liquefiable gases. Gases that can be easily liquefied would again be very easy to handle, very easy to store. Therefore, freons were very attractive in the industry. So Freon 12, that is CCl2F2, that is dichloro-difluoromethane, we would call it's known as Freon 12, is one of the most common freons in industrial use. It is manufactured from the tetrachloromethane by Schwarz reaction. So I told you that CCl4, tetrachloromethane or carbon tetrachloride, it is obtained from tetrachloromethane by Schwarz reaction, where that is used as a raw material here. These are usually produced for aerosol propellants, for refrigeration, air conditioning purposes. Your air conditioners have freons in them. By 1974, the total freon production in the world was about 2 billion pounds annually in 1974. Most freon, even that used in refrigeration, eventually makes its way into the atmosphere. Whatever you use freon for, ultimately, in the end, it is going to turn into a gas and it is going to go into the atmosphere. So since it does not affect us directly at that time, we feel it is not harmful, it's not toxic, but it is all going to go and collect up in the stratosphere, and it is going to remove the ozone layer. So in the long term, it has a very damaging effect. If the layer of the stratospheric ozone layer is lost, it would lead to more skin cancer. So it diffuses unchanged into the stratosphere, and in the stratosphere, freon is able to initiate a radical chain reactions, free radical mechanisms, that is radical chain reactions that can upset the natural ozone balance. And you've studied about this in class 11 in the 14th unit. Now we come to the last compound here, that is DDT, dichloro-diphenyl trichloroethane. DDT was first chlorinated. The first chlorinated organic insecticide was originally prepared in 1873. It is so old. But it was not until 1939 that Paul Muller of GG Pharmaceuticals in Switzerland discovered the effectiveness of DDT as an insecticide. He discovered that this DDT could be used as an insecticide. Who was it? It was Paul Muller. What was the year? It was 1939. It was discovered in 1873. Or rather, not discovered, I would say it was originally prepared in 1873. As an insecticide, Paul Muller was awarded the Nobel Prize in Medicine and Physiology in 1948 for this discovery. The use of DDT increased enormously on a worldwide basis after World War II. And that is when we had the Green Revolution, all of a sudden we were using it everywhere, all around the world, primarily because of its effectiveness against mosquito that spreads malaria and lice that carry typhus fever. So you could avoid typhoid, you could avoid malaria by harming these insects. So, however, the problem related to the extensive use of DDT started appearing in the 1940s itself. In 1936, imagine, it started being, in 1939, Paul Muller of GG Pharmaceuticals, he discovered the effectiveness of it as an insecticide. And in the 1940s, that means very soon after its use, the harmful effects, they started appearing. What were they? Many species of insects very quickly developed a resistance for DDT. You would spray the DDT, they learned to live with it. So they became immune to the effects of DDT. Many species, of insects, they developed a resistance to DDT, and it was also discovered to have a high toxicity towards fish. So all the agricultural water, when it rained with all the DDT sprayed all over the lands, all over the farms, the water would go into the rivers, the rivers would carry it into the sea, and ultimately we had DDT in our rivers, we had DDT in the sea, and it started affecting the fish population. It started killing the fish. So the chemical stability of DDT and its fat solubility compounded the problem. What does that mean? It means that DDT is very chemically stable and it is soluble in fat. So what do fish have? Fish have omega-3 fats, and the fish fat or fish oil has omega-3s. So it goes and it can go and get collected in the fat of the fish. And not only that, even in the human body, wherever we have fat cells, DDT will get deposited there and will not leave the body. And it is not metabolized very rapidly by animals. So it'll go and settle down in your fat cells, but the body does not know how to metabolize it because it's not its natural food. It is actually a toxin. So when you eat food that had been sprayed with DDT, some amount of it always remains in it, and when you consume it, it is somehow going to get collected in your body. And as you keep consuming more and more food which has been sprayed with DDT, the amount of DDT in your body keeps on increasing till it reaches that toxic level where you cannot take it anymore and it starts showing its harmful effects. So DDT is the problem, that DDT is not metabolized very rapidly by animals. Instead, it is deposited and stored in the fatty tissues. If ingestion continues at a steady rate, if you keep eating food that has been sprayed with DDT, then DDT builds up within the animal over time. And the use of DDT was banned in the United States as early as 1973. Although it is still in use in some parts of the world. But this is a very harmful chemical. So now I would again encourage you to divide all these. I just read out the remaining compounds. You could continue this table in your notebook and then prepare this table, and before your exams just one reading should be good enough to memorize what was important here. Equations. That there is just one equation here of trichloromethane, trichloromethane, and which combines with oxygen in the presence of light to give phosgene, and the second structure here is that of DDT. Memorize these and you're good to go for your exams. So with this we come to the end of this chapter, and I hope you found it interesting and you found it helpful. If you did, give it a thumbs up. Subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.